Hello, this is Alita from Science Starz, and if you're watching this video, it probably means that you received one of our science boxes for Christmas. So let's get started. So we will start by unboxing the kit for ages 3 and up. So inside, what have we got? We have a pack of Skittles. We've got some markers, a balloon with a bobble inside, and an extra one. We have rock salt, table salt, food coloring, decorations, glue, a pipette. A pipette is used a lot in science labs to transfer liquids. Pipe cleaner, filter paper, round filter paper, and foam sheets. You should have 2 foam sheets. Got your written instructions, a leaflet, and there will be hot chocolate or a chocolate melt and marshmallows. We will start with a chromatography experiment. You will need filter paper. You could also use coffee filter, a foam sheet, a pipette, a few different colors of felt tip markers, pipe cleaner, scissors, water, and a cup or something that you can rest your filter paper on that will allow for a lot of space underneath. So let's get started. Now, take a marker and start to color your filter paper. You can color anything you want on it. You can do a Christmas scene, or you can do squiggles or shapes or numbers or letters, and leave the middle bit empty because we're going to be putting water on it later, and we're going to be putting it in the center. So I'm just going to start by drawing some shapes. What we're going to be doing is an activity in separating colors. Now, you've probably mixed colors together before, maybe when you're painting or when you're coloring, but have you ever done the opposite, which would be separating colors? There is a scientific way of separating colors by doing something called chromatography. The word chromatography comes from the Greek words chroma for color and tography, which means writing. So what colors are you going to try to separate? We have 3 primary colors, and those colors can't be separated out. Those colors are red, blue, and yellow. However, when you mix them together, such as yellow and blue, you get a new color. Do you know what it is? It's green. So if you were to use the color green, you would be able to separate it out into yellow and blue. And when you mix yellow and red, you get orange. So if you had an orange felt tip marker, you would be able to separate the colors to yellow and red. So now I'm going to show you how we do just that. Set your filter paper on a cup or something similar. And then, so take your pipette, and first of all, I'm going to show you how to use it. Your pipette is for transferring liquids. So with your pinching fingers at the top of the pipette, close your pinching fingers so that you're squeezing the top of it, and then place the pipette into the liquid and open your pinching fingers while it's still in the liquid. That's the key. Open your pinching fingers while it's still in the water, and then you will see it sucking up the water. So then place a few drops in the middle of your filter paper, and this part here will be a slow process of watching the water spread through the filter paper. Now, while it's spreading, it's pushing colors along. But the colors are made of molecules, and every color has a different sized molecule, so they move at different speeds. The larger molecules can't move as far as the smaller molecules, so they stop at a certain point, and then the other colors continue to move. So that is how the color spreads and separates out into different colors. It's because the larger molecules have stopped where the smaller ones continue on, and the smallest molecules keep going and travel the farthest along the filter paper. So have a look here. You can see the colors starting to spread, and they will start to separate. Now, if you have a color that took a lot of colors to make it, for example, the color black, you will end up with a lot of colors coming out of it when you do your chromatography. I'm adding a few more drops of water because what I'm finding is I didn't add enough to begin with. So if that happens to you, just add a few more drops, but always add the drops in the middle of the filter paper. So the only thing to do now is to wait while the water makes its way to the edges of the circle. So now I've jumped ahead and the filter paper's all wet, so leave it to dry. Put it maybe somewhere warm if you want to speed up the process. And once it's dry, it's time to make your snowflake. So begin by folding it in half. You're folding the circle in half to make a semicircle, and then fold it in half again to make a quarter circle, and then one more time. And that's an eighth of a circle. Looks like a pizza slice. Okay, so now this is where we decorate it. So I'm cutting the tip off just a little bit. I'm gonna add some cuts or some slices in different places. I am cutting a triangle. It can be a bit tricky because it's a lot of sheets of filter paper that you're trying to cut through all at once. So make some triangles, maybe cut the corners off. Be creative. I'm doing a semicircle there. A few more slices and just leaving them there. Okay, so I think that's pretty much all I have room for. Oh, maybe just at the bottom here. Another triangle. Okay, and once you've done that, open it up and voila! What have we got? A beautiful, colorful snowflake. Wow, so that's our chromatography snowflake. Now, we're going to give it some extra support, so we're going to glue it to the foam sheet. So very carefully, glue your snowflake. Put some glue all around it. So then, stick it onto your foam sheet. Pat it down, make sure it's nice and stuck, and then cut all around the snowflake. And now you have your chromatography snowflake. So let's get it ready to hang on the tree. Take your pipe cleaner and very carefully poke a hole somewhere through the snowflake, and then bring the ends together and just twist. And there you have it, your chromatography snowflake. If you'd like to email us a photo of your chromatography snowflake, send it to info@sciencestars.com. Now moving on to our freezing melting experiment. You will need a pre-frozen balloon that was filled with water and frozen overnight, or until a complete solid. Then you will need to remove the balloon so that you just have the ice globe with the bobble inside. Place it on a plate or in a bowl and begin to investigate your... How does it feel? Does it feel cold? Does it feel wet? Today you're going to be melting it. Add add some food coloring to some water, and make sure to add a fair amount of food coloring to give it a nice strong color. Then take your pipette. Remember, it's used for transferring liquids, and you're going to squeeze your pinching fingers, put it into the water, open your pinching fingers to suck up the liquid, and then squeeze the liquid out onto the ice globe. So continue doing that and observe what happens. Does it melt quickly? Are you using warm or cold water to do this? And do you think that cold water would melt the ice globe quicker than warm water? Or do you think warm water would melt the ice globe quicker than cold water? The next thing to do is to take your salt. Now I'm going to start with the table salt. So take the little pouch of table salt and with a spoon, sprinkle a bit of salt onto the ice ball. And observe and see what starts to happen. Next, take your pipette again and suck up some of the liquid and squeeze it onto the ice globe again. And observe carefully to see any changes that might be taking place on the ice globe. Do you notice any cracks or crevices starting to form? Look carefully. You should begin to see lines forming around the ice globe. This is happening because salt lowers the freezing temperature of ice, which means it has to be a lot colder for ice to freeze. So the salt makes the ice melt more quickly than just adding water. So now take your pouch of rock salt, which is larger than table salt, and pour some onto your ice globe. Now investigate again what is happening to your ice globe. Add some water because it helps dissolve the salt, and the dissolved salt is what makes the ice melt. So have a good look. What do you see? You should begin to see even thicker lines being formed where the salt is melting the ice. So keep adding water and keep adding salt and see how long it takes you to melt your ice globe. The colored water allows you to see easier where the cracks have been formed in the ice globe. If you run out of water or if your plate becomes full, you can use the water from your plate. Just use the pipette to suck up the liquid, the same way you did before. When you finish melting all the ice, you will uncover a jingle bell to hang on your tree. Hope you enjoyed! For the Skittles experiment, open up the bag and pour them onto a plate if you still have your Skittles and didn't accidentally eat them, not realizing that they were for a science experiment. Put them around the plate in any type of shape that you'd like. I'm making a circle and I'm alternating the colors so I don't have two of the same colors beside each other. I ended up with a lot of orange in this one. So I'm making a circle. And once I've got my circle, you can also make the shape of a candy cane or tree or anything festive. But once you've got your shape that you're happy with, take some warm water. So I've got some water here in a beaker and start to pour it slowly into the center of the plate. Make sure that you pour enough water to go past the Skittles while you're filling the plate. And make sure to keep the plate nice and still. So wait and watch, and you will see the Skittles colors move towards the center of the plate with beautiful rainbow streaks. So the science behind this is that Skittles are coated with sugar and food coloring. And when you add warm water to them, the sugar and food coloring start to dissolve. They have similar amounts coated on them, so they dissolve at similar speeds and they stay in their lanes. So you can see it moving towards the center now. The sugar is moving to areas of water with lower sugar concentration. If the water is poured in the center, this is happening for each Skittle at about the same speed. You could also try this experiment by using cold water and timing it to see what the difference is between using warm water and using cold water. What do you think will happen? Have a wee think and make a prediction before you try it out. You might need to buy another bag of Skittles though. The fun thing about this experiment is that you can eat it at the end. Enjoy! If you have any festive plates or plates with decorations on them, you can be creative and put your Skittles in various places like I've done here. I've made a candy cane and added some eyes, and yeah, it's just for something different. And you can see the colors now separating and spreading. To make your Christmas sensory bottle, you will need decals, food coloring, glue, a clear plastic bottle, and water. So to start with, unscrew the lid of your bottle, and we're going to start with the glue. So open up your glue bottle and squeeze it in. If you find it difficult to squeeze out, there is a little piece at the top that you can remove, and that will make it easier to squeeze the glue out. The reason we add glue to the sensory bottle is because it makes the water that we are going to add thicker. How thick a liquid is called its viscosity. So it describes how fast or slowly a liquid will flow. A liquid with low viscosity, or that's thin like water, will flow quickly. So once you have all the glue in, now it's time to add the water. So fill it to the top, and if you'd like, you could add some dish soap or hand soap to the bottle if you would like to be able to make bubbles. It's your choice. I'm going to add a little squirt of hand soap in. There. The next step is to add some color. Now, I don't want to add too much color because then it will make it too dark to see the decorations inside. So I'm just going to add 3 drops of color. And as you can see, it's spreading through the water, but it's not mixing with the glue just yet. We're going to have to shake it up. So now grab your decorations and put in as much or as little as you would like. Once you've got the desired amount of decorations in your bottle, screw on the lid nice and tightly. And then we're going to shake it up. We want the glue to mix with the water, so we'll give it a good shake. And you can see the bubbles starting to form where I have put the hand soap in. By adding glue to the water, we have increased its viscosity, which means that everything is going to flow slower. So that will allow for the decorations to move slowly in the liquid. Why not try to swirl it around and see what happens? Can you get it looking like a tornado? Which decorations sink the quickest? Are there any that float and don't sink at all? Have fun exploring! So I added more water to my bottle and got rid of all the air bubbles,
and I noticed that the decorations moved slower. That was because I got rid of all the air. The air was making things move around very quickly. So give it a go and see what results you come up with. Enjoy!
This is Elite from Science Starz saying bye for now and Happy Christmas!